Welcome to 5G Hub. In this video, we will talk about 5G transport network. 5G technology is an innovation platform that will enhance our connected world. To deliver on this promise, 5G will demand the network supporting it to be as flexible as the services running on it. The following high-level 5G use cases are well understood and documented by the wireless industry. The first use case is enhanced mobile broadband, providing greater data bandwidth service with peak data rate of 10 gigabit per second and beyond. This data rate will enable new use cases such as augmented reality, virtual reality, or ultra-high density applications. The second one is ultra-reliable low-latency communication, providing ultra-reliable capabilities with availability in the range of 99.999% and extremely low latency features in millisecond range, like vehicle-to-vehicle communication over 5G network, for example, is one of use cases for this category. The third one is massive machine type communication, supporting extremely large number of devices in the range of hundreds of thousands per square kilometer. Essential for this application class are battery lives up to 10 years. The big challenge is how to support these use cases on the same network. Let's talk about evolution of RAN. Before 4G, wireless industry backhaul transport requirements was simple and were defined by cell site capacity requirement, number of voice users, low throughput applications, and certain performance metrics like latency, jitter, and availability. And if you remember, T1 E1 circuits met the need at the time yet. But beginning with 4G, the bar was raised. Large data throughput, 100 megabit per second, for example, demand, introduction of multiple input, multiple output or MIMO technology, better coverage, energy efficiency, and radio coordination technologies imposed the new and stringent requirement on the radio access network or RAN infrastructure. In addition, as radio became more robust, vendors began offering remote radio solutions. Radios were moved close to the antenna to avoid the significant losses caused by long coaxial cable and connectors. This strategy not only helped with improved RF footprint, it also reduced the calling cost as the radio equipment enclosure located at or near the base of the tower. Regarding 5G RAN, 5G RAN networks will evolve from the two-level structure of the baseband unit, as you see in the left-hand side of the page, and the remote radio unit, RRU, present in 4G or LTE networks, to a three-level on the right-hand side of the page, three-level structure that includes a centralized unit or CU, a distributed unit or DU, and an active antenna unit AAU. The part of the original PPU that is not real-time is split and redefined as a CU, which processes the protocols and the services that are not real-time. The original RRU and some physical layer processing functions of the original PPU are combined into an AAU. The remaining functions of the original PPU are redefined as a DU, which processes the physical layer protocols and real-time services. So if we are talking about 5G RAN architecture, centralizing the RAN is top of mind for operator building networks for 5G and come up in every operator transport discussion. The reason is the biggest transport network change in moving from existing 4G to a new 5G network is a centralization of the RAN functionality. The creation of the front haul segment between the remote unit or RRU and the distributed unit DU. For some, the new mid-hole segment between DU and CU function represent a big change. In this figure, for example, a CU and the DU are deployed separately, and the corresponding transport network is divided into three parts now, with front hole between AU and the DU, mid-hole between DU and CU, and finally backhaul above the CU to the core network. This is about 5G transport network. Thank you for watching and see you in the next video.